Hello, everyone. My name is Minhaj Udan. I lead the technical marketing team for the Catalyst 9000 access switching portfolio. Today, I'm going to talk about what we're doing with the Catalyst 9000 switching in the edge space, mainly focusing on how we are providing end-to-end encryption in the typical enterprise campus space. Again, I do have a jam-packed agenda in a way, given 30 minutes, but I'm going to first set a stage with respect to how we are defining this edge space in a typical campus with respect to Catalyst 9000 switching family, okay? And then I'm going to obviously focus a bit more on the IPsec, given, again, you have also heard Max and Lucas talking about IPsec being that cloud native security encryption mechanism. So I'm going to focus on that a bit more in this session, along with the use cases with respect to our enterprise campus, and also how we are automating this via the DNA Center. Because if you have configured IPsec, I know most of you have done it, there's a lot of configuration in it, right? Even if you mess up a single line or a single something, that's it, right? You will end up troubleshooting that IPsec for a long time, right? So we have done a lot of that automation and ease of use with respect to DNA Center, which I'm going to cover that along with the demo. So now talking about typical campus architecture, right? Again, it could be classified into like a large campus, a medium-sized campus, and then a small campuses, right? Or you could think about like a branches or satellite campuses, right? So one thing, again, if you look inside these networking segments, whether it is large, mid-size, or small, or the branch campuses, one thing that you'll notice is we do have this hierarchy in the campus typically, right? And in this hierarchy, we have access, distribution, and core, right? That is well known. But there is another layer, which is an edge layer, or also known as egress, sometimes egress layer, right? That is something which is basically front-ending your campus towards external entities or external networks like WAN and internet, right? So that is where that edge piece comes in, right? That is basically front-ending. And obviously, when you're talking to internet and WAN and all that, you need some form of secure communication channel, right? And again, even if you look at other spaces like a medium-sized campus, there you could probably get away with having that same core device acting as an edge device also. And if you look at branch spaces, right, even there you'll probably have just maybe just a couple of networking devices there, right? And maybe there that only one device sitting in that branch space will be acting as your edge device as well, right? But the important thing to note here is this edge device is basically responsible for securely connecting to both WAN and internet, right? And obviously, you need some form of encryption for all of this, right? Otherwise, your data will be compromised, right? Whether it is within the campus or even outside the campus, right? And that is going to be a focus of this session on how we are actually bringing in end-to-end encryption within the campus and also outside the campus. Obviously, IPsec will be one of the major points I'm going to talk about, but there are other encryption mechanisms which I will also highlight or quickly flash on how we are doing with the Catalyst 9000 switching family. Now, again, just quickly, again, I've talked about access, distribution, core. I've talked about Catalyst, access portfolio, core portfolio. I want to quickly flash this 9000 switching product family that we have, right? We've been shipping all the bottom products for a while now, for a few years now, but something that we have recently added is the 9300X and 9400X, right? They have been already shipping. And also on the core side, we have added 9500X and 9600X platforms. Okay, so some of these encryption mechanisms, which I'm going to talk about, these are exclusively available on the X-based platforms. Okay. Now, now let's start this journey of building this encryption step by step. Okay. So now, if you want to just start that encryption, how do you encrypt? How do you secure your traffic within a campus? We have been shipping LAN MACsec for a while now, since a lot of years. I mean, we've been shipping this for a very long time. And this is something we already support this across our entire Catalyst 9000 switching family. This is something you can actually encrypt end to end, all the way from access to the core to the edge. And obviously, this is a layer 2 technology. It encrypts at the MACsec layer, at the data link layer. So based on how you design your network, but all the way to that layer 2 segment, you can encrypt all your traffic within the campus, within the branch, large, mid-size, doesn't matter. It is supported across our entire Catalyst 9K family. And the best thing about this is it is supported in the ASIC, in the hardware. We can actually encrypt it at line rate.
So how much uptake are you seeing in this technology?
So this is actually very widely deployed encryption methodology on the campuses today, because again, people use this along with 802.1x, especially with respect to the host, because we support both switch-to-switch encryption and also host-to-switch encryption, as long as the host supports that, like, for example, any connect or any supplicant kind of a thing. So it is widely deployed, MACsec today. Okay, so this is good, right? Within the campus, within the branches, we're able to encrypt it. This is all good. However, but by the way, I just have one more quick slide for somebody who's not aware of the MACsec, right? We do this hop by hop, right? This is a hop by hop encryption. Once the device gets an encrypted traffic, or if it gets unencrypted traffic, it's going to encrypt it at the egress. Okay, and again, it's done in the ASIC layer. And at the same time, we support both 128-bit encryption and also 256-bit encryption on this. Okay. Now, this is all good, right? We were able to encrypt it. This is one step that we have achieved. We were able to encrypt everything within the campuses, right? But how about when we need to go beyond the WAN? Let's say I have a layer 2 service provider circuit, or maybe like a Metro E circuit, right? I want to extend that encryption across the WAN. How would I do it? Obviously, LAN MACsec will not work in that case. So this is where WAN MACsec comes into picture. This is something we have also recently started supporting on our core portfolio, which is 9500X and 9600X. Now, this is going to extend that MACsec encryption across the WAN also. Now, this obviously builds that end-to-end encryption. Now you have within the organization encryption, and you're now able to extend your encryption across the WAN also, okay? But there is a small problem here, right? Which is you need a dedicated layer 2 circuit, layer 2 Ethernet provider here, right? To be able to do all this encryption even across the WAN, right? So, but if you need to extend this over the internet, obviously that is where IPsec comes in, right? So this is where I'm going to talk about in detail in my next slides, but quickly highlighting the WAN MACsec piece here, right? So with LAN MACsec, obviously it was hop by hop encryption, and you needed directly connected links. But with WAN MACsec, we are able to bring in some difference. So there are some enhancements that go in WAN MACsec, with which we're able to build that MKA MACsec key agreement over the Ethernet transport providers, over the service provider devices, right? It doesn't have to be directly connected. We can actually build the session over the top, okay? And again, obviously, there are other enhancements. For example, it also exposes the 802.1q tag in clear because it's going over the service provider, but we encrypt the entire payload. Okay, so this is basically that WAN MACsec. Again, I talked about the limitations of these MACsec and WAN MACsec. Again, this is basically targeted for specific segments, right, within an organization, and again through the WAN. But when it comes to internet, right, which is where all the services are, all the applications are. You know, Lucas and Max talked about IPsec being a key component, right? Because that's where everything is happening, right? So that is where IPsec comes into the picture. So one thing I want to call out here is typically in the large size campuses, you would typically have a router in place or some kind of a VPN concentrator, or kind of maybe 8 Catalyst 8K routers there, which is actually doing that SD-WAN for you as well, right? Because it's a big campus, you probably have everything set up in place and you're doing SD-WAN along with IPsec there. But for those entities like branches and maybe small campuses where you don't need SD-WAN, right? But you still need a secure form of connecting to the cloud. This is where we are bringing in IPsec support on the 9300X platform and the 9400X platform, especially targeting the customers who want to deploy this in a branch space and maybe in the small campus space. Because typically in the large campuses, you would already have all your setup in place. So this is specifically focused on the small campuses and the branch campuses. You could leverage IPsec on 9300X and 9400X and then connect to the cloud securely. Now, a couple of things I want to decipher here. Number one thing, why we are doing this, right? The number one point is we want to bring in that consolidation. We don't want the customer to manage routers separately and the switch separately in the branch because he needs IPsec there, right? That is number one thing. Second point is, I'll come to that one second. So one important highlight I want to bring here is typically whenever we talk about IPsec, it's always about the bandwidth limitations because it's supported in CPU, in the software, even if it is supported in the hardware, it's only limited gig or meg that is supported through that IPsec tunnel because it requires a lot of computation with respect to all those cryptographic algorithms, right? But what we have done with the 9300X and 9400X platforms, because it's our own homegrown ASICs, because we don't use merchant silicons unlike the competition, we are able to get up to 100 gig of encryption engine so that we can encrypt at 100 gig at line rate with these platforms. Sorry, question.
You using Silicon One?
So currently on the 9300X and 9400X, it is not Silicon One, but it is the new UADP ASICs, which is mainly focused on the SEC as a technology, or security as a feature. Basically, again, commonly known as Unified Access Data Plane ASICs. These are flexible, programmable ASICs. It's the next gen of the ASICs that we are actually putting on these 9300X and 9400X. So this is how we are achieving that end-to-end encryption picture kind of thing, right? This is how we have achieved LAN MACsec within an organization, WAN MACsec over the WAN, and then IPsec to the cloud, okay? But again, mainly focusing now on the branches and the mid-sized campuses or the small campuses. Now, if you look on these platforms, I've talked about this being supported mainly on 9300X. It is already shipping. 9400X, it will get shipping since from November timeframe. That's a 17.10.1 release is the upcoming release coming in the November timeframe. And both of them have a dedicated 100 gig encryption engine. Okay, so these platforms can also, again, along with this 100 gig encryption with the IPsec, they can also do LAN MACsec at line rate, by the way. So there's no taxation of if you're doing this versus the other. You can do both at the same time, this at 100 gig encryption at 100 gig, and then LAN MACsec at wide rate without any issue, right? Again, we're going to support industry standards-based IPsec because you're connecting with different cloud providers, IKEv2, tunnel mode, ESP, encapsulation. We're going to support all the typical features like V4, V6. For now, we're going to support static virtual tunnel interfaces. In the future, we're going to support dynamic also. But again, V4, V6, multicast, NAT traversal, all the typical features will be supported with the IPsec feature set here. Okay, now with respect to the use cases, obviously one of the common use cases is building site-to-site tunnels, right? That is a very common use case. You could do that from the branch or small campuses to the data center or to the headquarters or even to the colo provider. Okay, that is one of them. Obviously, the new one, which we are obviously seeing a lot with a lot of our customers, is being able to connect to different cloud providers from the branch, right? And I'm going to go into little detail in both of them, starting with the Colo connectivity, because this is something we have recently partnered, not partnered in a way, we have recently tested with Equinix very recently with 9300X platform, where they tested our 9300 platform across different locations in their Colo location. And they were really impressive results that we came out with. In fact, we tested everything, V4, V6, multicast, and what we've noticed is, especially the latency was exactly the same, almost exactly the same as the non-IPsec traffic as well. Because we are able to do this in the hardware, they didn't see any latency issues. So it was a great effort and a great results that we came across all the protocols, V4, V6, multicast, and the latency performance was really, really impressive when it comes to that. So I just wanted to quickly highlight this platform being also used in the Colo. And again, this is for the customers who don't want to migrate to cloud directly rather than do some incremental steps, like go with the Colo first and then probably go to the cloud directly. Now, coming to the secure internet gateway, you can also connect to, again, Cisco umbrella and also like a Zscaler, third-party secure internet gateway. And we also support different types of policy-based routing as well, right? For example, you could push in all your internet traffic as a default route to maybe like one provider, or you could split your traffic between different providers, like have some traffic go through some tunnels to umbrella and some traffic through some tunnels to Zscaler, for example. So we support the entire split tunneling in a way. We support up to like 128 tunnels today. with up to like 256 security associations. So we're able to do split tunneling and do policy-based routing. Based on that, you could move your traffic across the tunnels to the different providers. Now, when it comes to actual cloud providers, obviously Azure, AWS, or even Google Cloud, you can set up IPsec tunnels from your branches directly, either to the cloud gateway on the AWS side, or you could do it on the transit side also. For example, we talked about Catalyst 8000V routers. So if there's a Catalyst 8000V or a CSI, you could host your IPsec tunnel to that as well. So we have tested all of this and works flawlessly. Again, it's industry standards based. So we have done all of that testing as well in the house. Now, one of the other unique thing that we have also done with our Catalyst 9000 switching platform is we're able to also support IPsec with BGP EVPN fabric also. Okay, this is something we have recently introduced on the 9300X platform. We're able to encrypt via the IPsec even for the EVPN fabric. Okay, and again, as you have probably known, we support both SDA and EVPN fabric, but we are currently supporting IPsec encryption along with BGP EVPN. There's something again unique to Cisco. Now, when we talk about IPsec, obviously there's a lot of complexity involved in configuration of IPsec, right? So we support automation via the DNA Center, which is our on-prem orchestrator. Or you could also use DIY, for example, any like ZTP, for example, for zero-touch provisioning and different types of APIs to configure it. But I'm going to highlight in my slides and also in my demo what we're doing with respect to the DNA Center. Okay. Now, before I jump into some of the details, I want to quickly talk about how day zero is done today, right? With respect to the new devices.
Before we jump into onboarding, um, I'm trying to get my head around the whole concept. It looks great from a security point of view. Oh, great, everything is encrypted. But I'm looking at this and I'm trying to mesh this with the average enterprise. Everybody's been going to SD-WAN. Where does SD-WAN fit into this? Because now all the traffic's encrypted. We can't look at the traffic. How are we? I mean, and part of the benefits to this, at least in my head, is okay. You no longer have to have a firewall sitting in the branch. Well, we still have to have an SD-WAN platform. Where is Viptela going to end up on the Cat 9K, or are you doing something else to be able to keep it there?
No, that's a very good question. Currently, we are targeting this specific IPsec support, especially for those customers who don't want SD-WAN.
Okay.
So this is specifically for those customers right now. So there's no plan to bring in SD-WAN functionality on the 9K boxes. So for those SD-WAN customers, they can continue to buy Catalyst 8K and leverage SD-WAN. This is only for those customers who don't need SD-WAN but need IPsec for connection to the cloud.
Because I was trying to figure out, because the benefit of having IPsec directly on the switch makes sense, but then we don't have the full package.
No, for the SD-WAN, you still have to go to the Catalyst 8K devices. Okay. Now, typically, going back to the topic of day zero, typically today, if you are bringing up a new branch with a new switch, but you probably would have a router in place today, right? With that, what happens is a switch comes in, gets a DHCP IP address, and then the router would basically, through the connectivity, forward it to our PNP Connect. Because with respect to day zero, you need some PNP server, like plug and play is what we use, which I'm demonstrating here. But you need some kind of a server which can push in the config when the box comes up, right? So for us, that plug and play server is a DNA Center. And we have this PNP Connect cloud, which is currently only doing redirecting to the DNA Center IP. So typically today, what happens is you already have a router in the branch. You bring up a new switch, Catalyst 9K switch, DHCP comes in, the PNP Connect will provide you that redirect to the DNA Center, which is our PNP server. And then the connectivity is established, and then you have that switch onboarded to the DNA Center. Okay, that's good. But the problem, but the new approach that we are going after is you're saying that for those customers, like I just mentioned, who don't need SD-WAN, you don't need a router, right? We're bringing that consolidation. You just need a switch. You bring in Catalyst 9K switch to the branch, you boot it up, right? That's the only switch in the branch, right? There's no router. So now it again gets a DHCP from the ISP box, and then again it goes through the PNP Connect. PNP Connect will provide that DNA Center IP. But this time, this switch does not have connectivity to the DNA center IP because this is a brand new switch, right? So there's no connectivity at all, right? For this reason, what we have done is there's no connectivity to the DNA center because this is a brand new switch, right? There's no router, right? So now the thing that we are trying to solve here is with the PNP Connect cloud is, okay, so what we are doing new with to solve that problem with just a switch in the branch is we have brought in a PNP as a service as a new feature inside a PNP cloud. Now this can actually push the config to the switch also. In addition to redirecting to the DNA center IP, now it's able to push the complete config on the box, which is this config. This is the IPsec config. So you're pushing all that config to the box, and then this box is able to build an IPsec tunnel to the front end router on the DNA center site, whether it is headquarters or maybe different campus, and then this switch is then onboarded to that DNA center, and finally DNA center can manage that device completely. Okay, so the new component obviously here is one is IPsec definitely, because of which there's no router. Number two is PNP as a service. That's a new enhancement feature that came in on the PNP side, which is now able to push in the complete config on the box. So one thing that you'll have to do is obviously go to the DNA center. You can pre-provision all of this. You can say which device, which serial number, when this comes up and tries to connect PNP Connect, you push the config to the box.
That license, is it required if you're using DNA Center? And can you do IPsec from the command line without DNA Center?
So you still need that license, yes.
Okay, just
You
wanted
still
to
need
make
that.
sure. I kind of figured, but
Yeah.
you know.
Whether you're using DNA Center or not, yeah, you still need that ETSIC license. It's like $1 license. So basically, I picked up my site, and then I picked up the virtual account, and then I picked up the device, which is going to come up in the new branch, and then I configured the management IP, then I configured the router IP, towards that router side, toward the DNA Center side, and then I configured the pre-shared key and then the host name. And basically, what happens just after that is once you configure everything, and the moment after that you bring up that new device, you power on that brand new device on the branch, it would automatically come up. It will contact the PNP Connect, but by that time, DNA Center would have already provided all the information to the PNP cloud, and the PNP cloud would have pushed the config, and the device would be onboarded to the DNA Center. So the next flow is the day N automation, right? This is where your device is already part of the DNA Center, right? It's already established the tunnel. Now it's already onboarded. You can manage that box through the DNA Center. Now you can pick that device, and then again, this is an example for connecting to the umbrella. Okay. So by the way, since umbrella is part of Cisco, we are also able to automate even the umbrella side also. So you don't have to separately go on umbrella and do the entire IPsec config, right? You just pick the data center on the umbrella, and there are some steps initially that you have to do, like some keys, so that the DNA center is talking to the umbrella beforehand. But after that, it's all smooth process. You just pick the data center that you want to pair with on the umbrella side. But on the switch side, you pick the switch, then you pick how many tunnels you want, whether it is 1, 2, 3, 4 tunnels, and then you pick the name, the tunnel source interface, and boom, right? And then you push the submit button, and then your tunnel basically comes up. And obviously, there are other options too. For example, I talked about being able to send like all the traffic to the umbrella, or you can send only selected traffic to. So you have those options. If you pick the selected traffic option, then you can pick the subnet that you want to select. And again, with that, you have policy-based routing as well on the DNA center. So this takes care of that complete automation, day 0 to day N automation for the IPsec tunnel with respect to the devices. Okay? And obviously, after your tunnels are configured and formed, we also support the monitoring of the tunnels also. So you can look, you can click on the tunnel, you can look at the entire, like how the tunnel is up or down. You can troubleshoot your tunnels also. Okay. And again, the entire process of how it contacts the PNP and all of that is actually recorded, and all the config which is pushed to the box, everything is actually pre-recorded. You can look at the config in the DNA center and all that stuff. Yeah, this is the entire workflow.
Also support the using BGP over IPsec to like AWS, their standard approach where you create an open VPN tunnel and use BGP for the routing.
So currently, I don't think we have tested that. Currently, I mean, We have only tested the IPsec config, but but the open VPN tunnel, I'm not very sure if you have tested that one with the AWS.
Okay.
Okay. But the typical standard-based IPsec, that's what we have tested with AWS and other cloud providers too, including Zscaler and Umbrella and all that.